Hello, hopefully part two. If I don't fall off me perch, I'll try if I get in closer. Yeah, okay, right, we're going to knock something over. I can feel it coming. First things first. Yeah, I'm going to knock the camera over. I just nudged it then. Oh, scientific calculator for this. You remember jumping ahead, part 3A, I blew up a resistor. If you didn't, watch this. That's why we need to take notice of load and power ratings of things. So the resistor that we will be using here is a power rating of 1/4 of a watt. So I want to know what the power dissipated by this resistor is going to be, both at 150 ohm and at 100 ohm. Remember the P equals IV or VI, and how we expressed V into V equals IR, so we can have P equals I squared R. That's what we're going to use, and we're looking at 20 milliamps. 0.02 squared, excuse me, squared times 100. We could do that being our rates, couldn't we? So at 100 ohm it's going to be 0.04 watt, 0.02. Oh, calculator's turned itself. 0.02. This one came from the 99p shop, but it's not as good as Poundland. Times 150 equals 0.06 watt. That's okay, that's well under 0.25 watt, which is all we needed to be. See, that was easy, wasn't it? That's the electrical sums done. The next thing, we've got 45 LEDs. If we go at 1 centimetre intervals, all plenty long enough. That would be 50 centimetres there. Rather than use the Sharpie, I'm going to try alternative method of marking these using rollerball gel pens from Poundland. Where else? 45 to 52.5 centimetres in we'll start. Right, okay. That's about an inch. That should be enough. So all I need to do is measure in 2.5 centimetres and mark it, really, isn't it? I don't need to draw anything. Let's first of all mark the 50 mark. Mark the 50 mark. Gel pen does work. It's always worth checking when things come from Poundland. How's that look? I'm back here. And that will be, it's not brilliant. I'm going to reinforce that with the Sharpie. That's where we're going to cut it off. Now if we come in 2.5 centimetres, could use that one, couldn't I? Right. That's 2.5. As a note to anybody who else is thinking of trying this, these gel pens are not brilliant on mini trunking. Hardly surprising, really. Are we still looking in the right place? We are. Okay. Now, these are 5 centimetre 5mm LEDs, and I'll prove that. This red one. That's not, the way you can see it, that's not 3mm, is it? That's 5. Shall we prove that? This didn't come from Poundland, this came from Lidl's, would you believe? Yeah, measure across there. 4.99mm. Can you see that? 4.99mm. I can't, not in that tiny little monitor. Oops. So if we put one there and the next a centimetre away, it'll be there. Shall we do them at 2 centimetre intervals? Or 1 centimetre intervals? There's another light bar around here somewhere that's all blue that I've used previous videos. No. Okay. Maybe 2.5mm, 2.5mm, that'd be 5mm between the centres. Okay. Or between the edges. Okay, we're going to do them a centimetre apart. All marked out, ready for drilling. I'm not doing that in here. You don't want a video of me drilling for hours and hours and hours. That's really rather boring. The next important bit that I said we'd do on this video is work out the design of the circuit. So, because this is designed for use on the same controller and this works, what we need to know is it common anode or common cathode? It's common anode. So that means the positive rail, if I somewhere to do it, will run at voila. And then we will have, I haven't got green, can't do it. We will have the other 3 rails running RGB. So that will be RGB. And they will run, the LEDs will run, so that's R, so there'll be times 3. There'll be 3 in series, 5 in series for the reds, that's the R rail, that's the plus VE rail, and there'll be a resistor in there. Yeah, right, that's easy enough. You can do that. That's it for now. Hope you all learn to speak chipmunk. See you soon.